Hey folks, welcome back to another video of the system design playlist. So today we are going to talk about replication and sharding. First we will talk about what is replication, that we will brief overview about sharding. Then we will discuss about what exactly database sharding is, what are the benefits of sharding and how sharding works. Then we will discuss about some sharding strategies. We will also do the challenges with sharding and best sharding practices. Finally, we will discuss about the summary. So let's start with the what is replication. Just like we add more application servers, we are adding more application servers to handle the traffic, right? We can scale our database by creating copies of it across multiple servers. What I am doing is I am having a primary replica, right? How it actually works. Let's say we are having a primary replica. We have this is actually one primary database. This is a primary database, right? And we are also creating replicas. Like we also call it as primary replica, and we are creating replicas that handle all the write operation. So what are the write operation? Like you are doing insertion, you are doing updation, you are doing deletion. We have multiple read replica. So what I am doing is I am creating multiple read replica, like replica 1, I have created replica 2, and I have created replica 3, right? That handle the read queries, right? So what these are doing is these are doing the read query, these are performing the select operation, right? Whenever data is written to the primary database, suppose you are writing some XYZ user data in the primary database, right? So it gets copied to the read replicas also. It will automatically get copied to these read replicas. It will automatically get copied to these replicas as well. So when you try to access these, suppose this primary replica fails, one of these replica will take over it. It will become now primary, and this will give you that data. So it will never cause you a downtime, right? So replication improves the read performance since read requests are spread across multiple replicas, and it reduces the load on the each one. Like it is reducing the load actually. This also improves the availability since if the primary replica fails, a read replica can take over the new primary. Let's say this primary replica is failed. This is not working actually. What this replica will do, this will take over. This will become a new primary replica now. So replication is great for scaling read heavy application. It is great for scaling the read heavy application. Always remember this. We will use this concept when we will be discussing the problems of the system design. But what if we need to scale writes or storage a huge amount of data? Like you have said, like we are going to do this for read heavy. But what if we are going to do the write heavy? How we can do that? Then we have sharding. We actually do this by sharding. We will discuss it. Let's discuss the replication improves the read performance since read requests are spread across multiple replicas. This reduces the load on each one. This is the formal definition. Now let's discuss about sharding. For write heavy, we need sharding. We have discussed for read heavy, we have the replication. For write heavy, we use sharding actually. So let's say our service now has millions of users. Our service is serving millions of users, right? And our database has grown to terabytes. Our database has also grown to terabytes. This is important. So a single database server will eventually struggle to handle all this data efficiently. A single data server cannot do that. Instead of keeping everything in a single place, instead of keeping everything in a single place in a particular database, what we will do is we are going to split the database. We are going to split the database into smaller, more manageable pieces, like 0 to 999. You handle these things. Let's say this is A, this is B, and this is C. And 1000 to 1999, you are going to do all these, right? And from 2000 to 2999, you are going to handle all these things. What we are doing is we are actually splitting a big database into chunks. We are actually splitting into chunks. So remember this word. We are actually splitting into chunks with a range like 0 to 999, 1000 to 1999, then 2000 to 2999, right? So this is actually known as sharding. This was a brief about sharding. What exactly is sharding? Database with 3 million rows. So let's say this is a database. This is a bigger database with 3 million rows. Now we are applying the sharding. So we are creating 3 shards with 1 million row each. It is handling 1 million, right? It is also handling 1 million. It is also handling 1 million. This is known as sharding. We are actually converting the database into chunks. But what we were doing in replication, we were copying. Like in replication, we were copying the data. We were copying the data so that if the primary fails, then some baby replicas will get over it. So we divide the database into smaller parts. We also call them shards. Shards are smaller part, or we can say these are the smaller chunks. Each shard contains a subset of the total data. So it is actually containing a subset of total data. Subset of the total data. Data is distributed based on the sharding key. Data is actually distributed based on sharding key. For example, let's say you have a user ID. So you are actually distributing the data across the chunks based on the user ID, right? So by distributing the data this way, we reduce the database load. We actually reduce the database load. And also each shard handles only a portion of query. This is also important. This is speeding up the read and write performance. So queries are distributed across multiple shards instead of hitting a single database, right? So this is also like doing speed up your write operation, both read and write, both read and write. Sharding is also referred to as horizontal partitioning. We also call it as a horizontal partitioning. So remember, we also call this as horizontal partitioning. Since the data is split by the rows, so we call it horizontal partitioning. If you have any question, you can ask in the comment section. Now let's talk about the benefits of sharding. What are the kind of benefits we have from sharding? So it is doing the performance improvement. Exactly. So by distributing the data across multiple nodes, what are the multiple nodes? These are the actual shards. What we are calling them, these are the shards, right? Sharding can significantly reduce the load on any single server. Like let's say there is an employee who is doing work of other employees as well. Now if that employee is going to say to two employees like, hey, can you do my work? Hey, can you do my work? So let's say A was doing all the work. Now B and C also came and they said like, we can share your work. What will do? They can do the work more efficiently, right? They will do more fast. So this result in faster query execution and improve overall system performance. And it also results in scalability. Sharding also allows databases to grow horizontally. Grow horizontally, we are splitting row wise. That's why it is growing horizontally. As the data volume increases, new shards can be added to spread the load evenly across the cluster. These are also causing high availability. Where the data is spread across multiple shards, the failure of single shard does not bring down the entire system. Let's say this was a particular shard, right? We have splitted this into chunks, right? So if this 0 2 is failed, this will not cause entire system to fail because other shards are working fine. Only this will fail, right? Other shards can continue serving the request, which ensures higher availability. Now, if I talk about the geographical distribution, sharding also allow you to strategically place shard closer to your user. it also reduces your latency and improving the user performance. Okay, let's take an example. You are staying in Delhi, right? So let's say I have created a shard on a node, or we can say virtual machine, which is near to your location, which is near Delhi, right? So your data will store in this shard instead of a shard which is much away. So this is also allowing you to strategically place the shards close to your server, to your user, right? And you are reducing the latency, you are reducing the delay and improving the user experience by improving the speed time to retrieve the data. It is also reducing the cost. Instead of scaling vertically by investing in more powerful and expensive hardware, sharding allows for cost-effective scaling by utilizing the commodity hardware, right? Instead of scaling vertically, you are not actually improving the machine by adding more storage, by adding more database. You are doing horizontal scaling here. So sharding is cost-effective by that. How does sharding actually works? Do you know that how sharding actually works? The first is we have sharding key. What is a sharding key? The shard key is a unique identifier which is used to determine which shard or a particular piece of data belongs to, right? It can be a single column or it can be a combination of columns, so it is all about the shard key. Then we have data partitioning. Partitioning involves splitting the data into shards based on the shard key. Each shard represents a portion of the total data set. Common strategies to partition the database are like either you can partition the database based on ranges, or you can partition based on hash, or directory based sharding, right? Then we have shard mapping. So we are going to create a mapping of shard keys to the shard location. After that we do shard management. So the shard management oversee the distribution of data across the shard, like what data you have distributed across multiple shards. Like we were distributing like 0 to 999, then we were discussing like 1000 to 1999, or we were distributing like 2000 to 2999. This is how we were distributing the data, right? So it also ensures data consistency and integrity. It is also doing query routing. Query routing means like it intercepts the incoming query, whatever query is coming to the database, and it directs them to the appropriate shard based on the shard key. So based on the shard key, we are directing to that particular shard. Now further, let's talk about the sharding strategies. The first sharding strategy is hash based sharding. How do we use hash function to do the sharding? So data is distributed using a hash function which maps data to a specific shard. This is mapping the data to the specific shard. Here you can see the data is actually mapped to the specific shard. It is based on the hash value, right? So let's say you are having any column, let's say A, B, C and D. Then you are actually applying the hash function. Hash function is providing you the hash value corresponding to the column. So it is providing you the actual hash value corresponding to the column, and based on the hash value you are mapping it to the shard. Let's say there is hash value and it is pointing to shard 1, and there is also hash value which is pointing to shard 2. This is how the hash based sharding works. So let's take an example. Like what do, you are using the hash function, and in the hash function what parameter do you give? You are actually providing the user ID, right? And then you are doing modulo by 2. It determines the shard number. So it is actually determining which shard number 2.2, right? For a user, you are distributing the users evenly across the two shards. And let's say if you wanted to determine further, you will use the same hash function, or we can say you are going to update more shards here. Like so, let's say it was also pointing to some shard 3. So you are using the same hash function to find to which shard you are pointing to, right? If I talk about the second strategy of the sharding, it is range based sharding. What do we do in range based sharding? Data is the distributed based on range of values. So such as, for example, you have date or you have number, right? Shard 1, here you have the shard 1. It contains the record with IDs from 1 to 10,000, right? It is actually containing the record from 1 to 10,000, and shard 2 contains record with ID from 10,001 to 20,000. So it is containing from 10,001 to 20,000 and so on. This is how, in the form of range based sharding, you are storing the data. And then the third strategy is geo based sharding. What is geo based sharding? Data is distributed based on the geographic location. So let's take an example. Let's say there is shard 1. Okay, so let's say this is shard 1, and this serves users in North America. This is serving the users in North America. There is shard 2. Let's say this is also a shard. This is shard 2, and it is serving in Europe. It is serving in Europe. There is shard 3. There is shard 3. It is serving in Asia. So these are based on geographic location. Like in whichever area you are serving, just make the shard close to that area on the virtual machine or on the server which is situated to near to that location. The fourth strategy is directory based sharding. What is directory based sharding? It maintains a lookup table that directly maps a specific key to specific shards. How it is doing that? So let's say we have a table. We have this column 1, 2, and 3, and we have some record A, B, C, and D. This will actually convert to, like, based on the column, we have the shard ID. Here we have the shard ID. We are already assigned that S1, S2, S3, and S4. So based on that, what we are doing is we are going to convert it into directories. So let's say there is column 1, there user A, right? This is directory 1, this is directory 2, and this is directory 3, and this is directory 4. We are already assigning the shard ID and we are splitting into multiple directories. This is known as directory based sharding. What are the challenges that we suffer when we do sharding? So the complexities are, sharding introduces additional complexity requiring careful planning and management. Data consistency, it is maintaining data consistency across like sharding can be challenging, especially when data needs to be joined, like when you are performing join operation. When you are performing the join operation, it is not suitable, or we can say aggregated from multiple shards. Across shards, like we have cross shard joins. These are performing join across multiple shards. This can be very complex and computational expensive. We are also doing like data rebalancing. So as data volume grow, as the data volume is growing, the shard may become unevenly distributed, which require rebalancing to maintain an optimal performance. So these are the challenges. What are the challenges? We have first, it is also increasing the complexity. It is causing data inconsistency. It is how we can implement joins if we are using relational databases. So on cross shards, we won't be able to do the joins. It is also causing data rebalancing because it requires rebalancing to maintain the optimal performance, right? Now let's talk about what are the best practices for sharding. So first you have to choose the right sharding key. This is very important. Select a sharding key which ensure or even distribution of data across multiple shards and aligns with the application access pattern. Like you are equally distributing the data across the multiple shards. You are equally distributing the data, right? Use consistent hashing. Implement a consistent hashing algorithm to minimize the data movement and when adding or removing any shard, right? So what happens is, let's say I am removing this shard. I am now removing this shard completely. Okay. Now my hash value change, but the hash value is not updated, so it will cause me inconsistency. And monitor and rebalance shard. Regularly monitor the shard performance. Data distribution, you do rebalance shard as needed to ensure the optimal performance. You can handle the cross shard query efficiently, like we have seen what are the problems of sharding. We cannot do cross joins, right? So we can optimize query that require data from multiple shards using techniques like you do query federation, you do data normalization, and then we have plan for scalability. First you choose the right sharding key, then you do the consistent hashing, then you do monitor and rebalance the shard, then you handle the cross shard queries. After that you plan for scalability. Design your sharding strategy with future growth in mind, like consider how the system will scale data volumes and traffic increase. This was all about this video. I hope you like this video. Do mention in the comment section if you have any doubt, if you have any kind of question regarding the video, regarding the playlist. We'll see you in the next video. Thank you. Do like, share and subscribe my channel.